Everyone, welcome to Cassandra.Lunch number 102. We're going to go ahead and give everyone a couple more minutes to file in and we'll get started. Alrighty, let's go ahead and cut the music. Hey everyone, welcome to Cassandra.Lunch number 102. Today's topic is going to be on choreography versus orchestration, and we're also going to take a look at Google workflows in the context of Cassandra as well. And today's talk is going to be given by Stefan Nikolovski, who's an engineer here at Anant. Co-organizers for the event are Rahul and myself. If anyone is interested in being a guest speaker for Cassandra.Lunch or Data Engineers Lunch, feel free to reach out to me. My email is below. Sponsoring Cassandra.Lunch or Data Engineers Lunch, feel free to reach out to me as well. We are part of Data Community DC. Data Community DC believes in building an inclusive environment, so no matter your race, gender, sexuality, and orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built up of a bunch of different organizations. Data Engineers Lunch falls under Data Wranglers DC, so if you're interested in all the various events put on by Data Community DC, you can find out more at datacommunitydc.org. So what do we cover here at Cassandra.Lunch? We cover everything that is Cassandra, talks Cassandra, or plays well with Cassandra, whether that be open source, enterprise like DataStax, Scala, Yugabyte, managed variants such as Keyspaces, Cosmos DB, as well as things in the ecosystem that play well with Cassandra like Spark, Kafka, Airflow, etc. So if anyone is interested in giving a talk on anything Cassandra or in the ecosystem, feel free to reach out to me. Group rules, if you have a question, ask it. This is meant to be a community, so the more you know, the more everyone else knows, as well as the more you want to ask questions, the more interaction we can have with the community. If you're watching this on YouTube, don't forget to like and subscribe, and feel free to ask questions in the real-time chat. We'll have people in there as well to monitor for questions and comments as well. And again, please be polite and courteous to the speaker. They may have preferences and when they prefer questions, But again, you can type them into the chat and the speaker should be able to get to them at a good stopping point as well. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. DataStax is a partner and sponsor. GW University helps provide venue space when we have in-person events. We also have some organizational institutional sponsors. If anyone has any announcements, if they're offering jobs, looking for a job, if they have any meetups, hackathons, conferences, or summits that they would like to promote, feel free to drop links and we'll get them transferred to and from. DataStax Astra's Buildathon has completed. Anant is hiring for full-time or part-time positions, data platform operators, engineers, architects. You can find out more at careers.anant.us. Upcoming events, again, Cassandra lunches happen on Thursdays, currently at 12 p.m. Eastern, but we are looking at having a more variable time slot to cater to a worldwide live audience. Same with data engineers lunches, which happen on Mondays at noon Eastern. All these videos up until Cassandra lunch number 10 till today are available on our YouTube channel, youtube.com/AnantCorp. And they're all available on the Cassandra Lunch playlist. Cassandra.Link should be your number one resource for all things Cassandra. We curate, hand curate resources of anything relating to Cassandra and the ecosystem in context of Cassandra. And we host it on our site, Cassandra.Link. So if you have any questions or you want to find something more, any resource related to Cassandra, check out Cassandra.Link. And we also have released our third runbook for Apache Cassandra. All these runbooks are free. We'll drop the link below. You can click on the link and fill out the form, and we'll send you over our third Apache Cassandra runbook. And with that, we'll go ahead and pass it over to our speaker for today, Stefan.
Thank you, Armand. All right. Hello, everybody. All right. So today we'll be talking about Google workflows. And just before that, we'll kind of quickly cover choreography versus orchestration. It's kind of like the way that brought me to Google workflows. Yeah. So what choreography versus orchestration? So choreography and orchestration in like the line of serverless in software engineering terms are two modes of interaction in a microservice architecture. In orchestration, there is a controller, the orchestrator, that controls the interactions between services. It dictates the control flow of business logic, and it's responsible for making sure that everything happens on cue. This follows the request-response paradigm. In choreography, every service works independently. There are no hard dependencies between them, and they are loosely coupled only through shared events. Each service listens for events that is interested in and does its own thing. As always, neither is necessarily better than the other. Depending on the context, one might be more appropriate than the other. And since Lambda itself is inherently event-driven, the choreography approach has become very popular in the serverless community. Let's kind of like first talk about the choreography approach. So we'll take an example here. We're building a food ordering service where customers can order takeaways from your favorite restaurants. A typical order flow might involve the following steps. Customer places an order, system notifies the restaurant accepts the order, and then the system notifies the customers and the food is delivered to the customer. And now if kind of like take a look at this more in-depthly from the perspective of a software engineer, we can model these 5 steps as events: order placed, restaurant notified, order accepted, user notified, and order completed. So with these events, we can implement the order flow using the event-driven approach. Like number 1 would be a customer places an order. Number 2 would be place order function publishes an order placed event. Notify restaurant function is triggered by the order placement event. Notify restaurant function sends a message to the restaurant SMS. Then step number 5 would be notify restaurant function publishes a restaurant notified event, and so on and on. And you can kind of see in the picture here what I'm talking about. So every function acted completely independently. None of them had the notion of the overall order flow. They each only cared about. So I think we have Okay, that's something else in the chat. So, oops. Okay. Oh, that's Astra for the demo later. So, what are the pros and the cons of the choreography approach? So the pros are each step of the flow can be changed independently. Each step of the flow can be scaled independently, no single point of failure. Other systems can be built on these events. Example, promo code service might be interested in the order complete event. The events are useful artifacts on their own and can be fed into a data lake to generate business intelligence reports. The cons, on the other hand, would be an end-to-end monitoring and reporting are difficult to implement timeouts, and the overflow is not explicitly modeled and exists only as an emergent property of what the system does. Yeah, from a business point of view, it also begs the question, are these really separate processes or are they different steps with one process? For business critical workflows like this, wouldn't you want someone or some team to take ownership of and be responsible for it? When something goes wrong and you lose millions by the hour, do you want a room full of people looking at each other, or there's a few people that know the full function of these processes, and then what happens if those people leave? So now let's kind of take a look at the orchestration approach. On the right, some easy step functions, and we have Google Workflow example here. We can kind of see what everything I was talking about previously, kind of explained here. So to implement the orchestration approach, we'll probably do like something like step functions and model the order flow as a state machine. It's also worth remembering that although we no longer need to use events to trigger the next step of the order flow, those events are still useful artifacts on their own. So we should publish those same events from task states in the state machine. For example, after the notify, user state notifies the user via SES. The task should also publish the user notified event. This means we can still decouple the order flow from that business units that wish to build features on top of events related to another. The aforementioned promo code service can still rely on order complete events as before. So kind of like we can talk about the pros and cons of the orchestration approach on the other sense. So an end-to-end monitoring and reporting are trivial since step functions gives you a built-in visualization and audit histories. It's easy to implement timeout, example for a restaurant to accept an order for the total duration of the order. Business logic is in one place and it's easy to maintain and manage. The order flow is modeled and source controlled. You can literally see it in the step functions console. You can even see it in the source of the Google functions, Google workflows, and I'm going to show you that later. The order flow is modeled and source controlled. Yes, it's important that it should count as two pros. Cons, so I have to learn yet another service. And it's a AWS service, but it can be other services as well. There's Microsoft version of this, and there's Google version of this. At $25 per million state transaction, which counts start and end, by the way, step function is a pricey service. I'm not sure if this is relevant. I kind of got this information. Maybe this is outdated a little bit, but you know, I haven't really tested Google Workflows that much to see how much it costs. I don't think it costs that much. And yep, so let's talk about Google Workflows now. Kind of move away from step functions in AWS. So you can combine the Google APIs and services to build reliable application, process automation in data and machine learning pipelines. We can deploy and execute a workflow that connects a series of services together. Reliability, automate process that include waiting and retries for up to 1 year. Implement real-time processing with low latency, event-driven executions. So the benefits are you simplify your architecture, Stateful workflows allow you to visualize and monitor complex service integrations without additional dependencies. Incorporate reliability and fault tolerance. You can control failures with default or custom retry logic and error handling even when other systems fail. Checkpointing every step to Cloud Spanner to help you keep track of progress. There's zero maintenance, which is called scale as needed. There's nothing to patch or maintain. Key features are it's a reliable workflow execution, call any service from cloud functions to private and third-party APIs. Connectors make Google Cloud services particularly easy to use by taking care of requests, formatting retries, and waiting to complete long-running operations. Again, if you Google Cloud and you have a lot of services that you're paying there, it's very well integrated into the Google APIs, as long as the external APIs. But Google's API, they have a lot of plugins, connectors that you can use, like something like BigQuery, Big Data. It has powerful execution control, use expression and functions to transform response data and prepare request inputs. And it's pay per use, only pay when workflows take steps. There's a few use cases here on the Google Workflows application website. So we have app integration and microservice orchestration. As we talked about it, you can orchestrate a lot of microservices with it. So you can combine sequences of service invocations into reliable and observable workflows. For example, use a workflow to implement receipt processing in an expense application. When a receipt image is uploaded to Cloud Storage Bucket, workflow sends the image to Document AI. After processing is complete, Cloud function determines whether approval is required. Finally, receipt is made visible to users by adding an entry in a database. It's Firestore, or you can do it in the database. So business process automation. You can use it for data and machine learning pipelines. You can implement batch and real-time data pipelines using workflows that sequence exports, transformations, queries, and machine learning jobs. Workflow connectors for Google Cloud services like BigQuery make it easy to perform operations and wait for completion. Cloud scheduler integration makes it simple to run workflows on a recurring schedule. You can use it also for IT process automation. And it's a really cool thing to have to learn. I kind of came across it, and that's why I kind of went to learn a little bit about it and more about why it was created. Henceforward, I kind of learned about the choreography and orchestration part of this. So that's kind of about it of the presentation. Now I have prepared a demo. Well, I kind of prepared a few workflows for everybody here. But before I go with that, is there any questions so far? Okay. Okay, so I'll take that there is no questions. First of all you have to do is create a Google Cloud account and find the workflows, enable it, and then you'll get to this GUI on the browser. You can use it through let's see. I think I don't have this. You can use it through a console as well. But I'm not going to use the console right now. I'll just use this because it's easier to show. You can create a workflow pretty easily, just 2 steps. You then give it the name, and then you define the workflow. So let's kind of like take a look at the hello world workflow. We can see the source, and this is just basically returns a string hello world. You have metrics, how many times it's executed. You have the number of executions. Everyone has an ID, time and duration. And then you can execute again, or you can just execute it as well. This is logging. You can select what kind of logs you have. You can have errors only or all calls. When you execute it, this is the input, just an empty JSON object, but the output is hello world because we're not putting anything. There's no logs because we just showed anything. But yeah, you have some information here. Again, it kind of reminds me of something like Airflow, but in just cloud hosted. Again, you can take a look at the logs more in-depthly here. There's details. Now, there's triggers. You can add triggers, which can be actually a cloud scheduler, maybe a certain run at a certain time, or an event arc, something when an event is triggered, this workflow gets triggered, basically. And then this where you can use the which is it event arc, something from Google that you can use for this. Again, the source permissions, right? So this is pretty simple. Let's kind of take a look at the next one, which is going to be calling an HTTP endpoint. And you can see that I already tried this a few times today. And it worked last time. So we'll just go straight to the source. So this is the way you structure it. As you can see here on the right side, there is a visualization of the code you written here on the left side. It's pretty straightforward, right? It's a YAML file. So you declare, you just said get microservice, the name of this microservice. It's a call HTTP GET request. For the arguments, we have a URL and the result, state result, and then we say state result dot body. I don't know why this name state result should be something different, but I think this is some random API that I found online. I think you put in your name and it gives you some kind of information for it. Let's take a look. I forgot about. Okay, age. I think it gives you some kind of information based on your name. And again, you can see the log details here. You can go through them one by one and see if there's something you need to debug or something like that. Oh, okay, yeah. Let me see. I think this would be better, right? Now, so again, I create. Okay, let's talk about Astra. Over here, Astra is just a cloud-hosted Cassandra database from DataStax. It's actually hosted on Google Cloud as well. So I'm going to use it as an example of just getting stuff into Cassandra, into Astra, grabbing stuff into it. And this is the first very simple thing that I wrote, which is, so let me see, can I see it? Okay, so we have first, which is get Astra call get request to the URL. So the URL will be your ID, database ID, and then the key spaces, and then the table, and then the ID of the item you're trying to find. So what it does is it gets an item out of Arpan, it seems like the code is YAML. Are there any other ways to write code itself? Not that I know of. It looks like it's YAML. I don't see anywhere to change it to be something else. So I'm assuming it's just YAML. But when I was digging through the what's it called, documentation, I did found like a lot of languages, but maybe that's just for Google functions, which maybe you can just integrate into workflows, if that makes sense. So you can write anything in the Google function, you can write in Python and then just implement it using the API, the Google API, and then just call that function, if that makes sense. So we're getting the result. We're sending the leaves info, and then we're doing a post request into, so this is the same database, but let's say this is different microservices, different databases, right? So we're just grabbing from one database and we're posting to another. So we're grabbing a certain item into one database and we're posting it into another database. So we're seeing, again, the headers is Cassandra. This is the Cassandra token. We have the body of the requests, the post request, which is just the ID, and then we have the information, which we got here. It's result info, and then like the specific field that we're trying to implement. And then the result out of this will be just like the log info, which will be the call, what will happen, the response when you do the call. So first of all, I'm gonna, I think this was which table, this table. Okay, so yeah, so we are pushing to clean data. So I'm just gonna say like this. Let's see, we're doing content, right? Content. So what we're going to do is we're going to say drop table, right. Okay, so let's say we're going to create the table once again. Okay. Okay, so we see we have this table, and after we run this workflow, again, this is the output of the post request. We should have it here. So there we go. Again, this could be triggered by some event that happened, or this could be a scheduled update or a batch thing, and it will just run. It will just update your database automatically. So this one, again, is pretty simple. Again, we're just grabbing stuff from one place and we're posting to another. The last workflow that I'm going to show you guys is kind of a little bit more complicated. Well, not complicated at all, but it's a little bit more complicated than the last one. So there are other ways that you can iterate and define variables here as well in the YAML file. So what we're going to do here is we're going to say we're going to get some information from one microservice. And in this case, we'll just grab leaves information, and it's going to be, we say grab 10 of them, and we're going to store the response into leaves info. And then we're going to define an array, and we're going to say so this is kind of like indebted, so we know that we're going to assign the result of this call into this array, this so this variable, and then we will define a condition which says, if it's less than the length of the array, iterate. If next, just return to result, which is this place here. And on the right side, which is pretty cool in the visualization, you can kind of see the condition. So when I say check condition, you say if I is smaller than the length of the array, go here, go to the next step. And so here we have an iteration where we iterate. So what do we do? We grabbed 10 leaves, right? And then we want to post those leaves into another table. And so I'll drop the table. and I'll show you what I mean. Again, just to do this, this is another microservice. In this case, can be Astra, and then we'll just push all these 10 results one by one, do 10 calls to Astra, and then push out the ID in the title into this table, and this table is going to be called the batch table. So batch data. Okay. So I'm going to create a table. This one's going to be some content to this title. Okay, so we see we have an empty table here. So we are going to run this workflow. Okay, it has succeeded. Again, the logging is not good. You know, obviously you can do a lot more here information for the logs. You can see where the the duration and more of, we can have more logs is what I'm trying to say. But again, you can see here. So let's kind of go to the database again. And we can see that we have mapped all these leaves informations that we grabbed from all microservices, and then we pushed into Cassandra. Now, obviously, this is still pretty simple. It's just doing a bunch of iterating. But I wanted to showcase that the visualization, which I think is pretty cool. From this, well, as you write the code on the right side, it'll get visualized, and you can kind of see more clearly what you're doing. Again, you can make, for example, grab some information from one microservice, and then you can send them to another microservice where that data will be processed or cleaned, right? And so then you send back that data again into here, and then you push the clean data into another database, and so and so. If you guys want to check out more stuff, there's this workflow demos here from Google Cloud Platform. I took a look at some of them. They are pretty cool. This one, service chaining, is pretty cool. And there's there's an example here for really good examples here if you guys want to take a look at that and kind of like play around with it. Let me see, was there something else? Oh, yeah, again, if you want to use connectors, like I said, Google Workflows has connectors for these products here. Another a good thing that I found was this BigQuery connector. So you don't have to do a lot of the stuff. So there's like a lot of let me see. So a lot of functions here that they're already written for you. Like delete, get, insert, patch, update, and then you can kind of like go through this. Again, this BigQuery, I'm assuming is part of big data. It's like NoSQL database that Google offers. But again, there's a lot of stuff here. There's an SQL, Cloud SQL admin connector that you can use. And yeah, does anybody has any questions so far? Does anybody want to add something if they worked with Google Workflows?
Yeah, I have a question. So related to the connectors, it looks like they're all Google native connectors. So I guess my question was going to be, perhaps like there could be a Cassandra connector, but looking at this connector list here, it doesn't look like it. Like just straight up, they have it right away. So I guess like you would still be able to connect to a Cassandra or some variant that you can talk to via in the similar way you did, right? Because Astra, you just use the Stargate APIs. So if you have like a Stargate layer on top of something, it looks like you should still be able to run this either if you switched it from native Astra to like open source Cassandra, but then you had Stargate and then just talk to it via Stargate.
Yeah, I mean, my first plan was to do exactly that, but with the lack of time, I just decided to use the Astra. What I was planning to do is just run Cassandra or maybe Cassandra on DigitalOcean using Kubernetes, right? And then it has a Stargate layer, and you can just expose the service, and then you can talk to Cassandra, which is just Apache Cassandra, the free version, and then you can use that to connect and talk to your database that way to Cassandra, right? And I think there should be like more ways to do it. I know Astra you can use something else. They have connectors. I didn't really see if they have connectors for Google or something. Let's see. No, I guess not. Maybe GraphQL. But again, yeah, there should be a few ways to connect to Cassandra other than just being. It has to be Astra or Stargate.
Gotcha. I guess like what you mentioned before when you're talking about like a more complex series where you go from one microservice to another microservice. So like if you have some kind of messaging microservice between layers, right? Granted, it might be more work than you would need, but if you have some process, I guess, like if you start with your get URL and say that's like if that's data that needs to be wrangled, you could feed it to some Spark or Kafka where you can do some KSQL or Spark SQL or just some basic transformations to clean it up, and then feed that back into the service. So like, do you know if you can connect? I guess I didn't see them specifically on there, but I'm assuming I think I saw GKS on the connector list. So yeah, if you have like, I'm thinking if you have like Kafka or is there data proc on here? Google data proc, no, but I don't know. Maybe you could probably run open source Spark or actually if you use PubSub, potentially that could be a messaging bus. But yeah, it's interesting. I looking at this here. So like, I think I may have missed it, but you were just manually hitting execute. So you mentioned related to it's similar to Airflow. So are there options to set scheduling on the workflow if you don't? Okay, so Cloud Scheduler. Okay, cool. So yeah, I think because I was thinking this is also kind of similar to like it's a in between like Airflow where it's like Airflow you need to write the code and then you can obviously put the orchestration on top of that. But I think it's similar to NiFi and stream sets in a sense where you can write low code, no code. Like this, I would consider low code, right? You don't have to write a lot of code, but it's a way to, it's not necessarily no code, right? Like, but it's still an easy way to just write a YAML file and set up an orchestration, which I think is interesting.
Yeah, you're right. You can use the Cloud Scheduler or event or PubSub message. So EventArc is a service. So I am assuming it's something that Google has where you can control the events, right? I'm not really familiar with it. It's kind of like on top of my head, but it's pretty cool what you were mentioning. If we can import, we can use Kafka or somewhere inside the workflow, and in that case, that would become kind of a hybrid way of. It wouldn't be orchestration or choreography. It would be a hybrid way of doing stuff, which would be pretty interesting to do. I'm sure it exists. Maybe if Raul was here, he could have like kind of talked about that. But yeah.
All right, yeah, we'll open up the floor to more questions. If anyone is watching on YouTube right now, I see a couple people. Don't feel free to drop comments, and we can get them, or questions as well. We can them taking a look at as well. Or if you're on the Zoom chat here, feel free to speak up or drop something in the chat if you're feeling shy.
Stefan, I do have a question. The graph display where it was sort of showing the steps. Yeah, so this looks like it's generated by the code on the left. Is that right?
Yeah. So you write the code and then this gets generated on the right.
Is there anything that you've seen that suggests it might be able to go the opposite direction, where you go from the diagram to the code?
No, it's basically like Arkham was talking about. It's kind of like NiFi, I guess, where you can just like kind of connect to it. But no, so far that I know, but you just write the code. For me, I just started writing the code and this started showing up on the right, which is pretty cool though. You kind of get to see your whatever you're doing here, your workflow, right?
Yeah, there just seem to be a lot of applications now that are trying to generate this graphical view. I'm actually going to be working on demoing another one of these sort of next week. It's just fascinating that this is the direction that the industry is going, with this visual display being something that it's almost just coming to be expected. This like architecture look, this diagram just seems to be becoming more central to the coding process. Yeah. All right, thanks, man.
All right, thanks, Nick. Yeah, it's a good thing to have. I like it. Again, maybe if you have an even bigger file, it would be even easier to get to kind of like visualize everything. But just if it's done for you, and you're all good to go. Okay. If there's not any more questions, I'm gonna stop sharing. And
thank you everyone for joining us here for Cassandra.Lunch. If you're watching on YouTube, don't forget to like, subscribe, and also turn on your notification bell, so that way whenever a video is posted or whenever we do go live, you get notified. And with that, we'll wrap it up for today. Don't forget to get Anant's Apache Cassandra Runbook number 3. It was released last week. It's only going to be here for a limited time, so don't forget to get it while you can. The link is listed in the Zoom chat as well as the YouTube chat. And with that, we will wrap up and see everyone on Monday for Data Engineers Lunch. Take care.
Everybody.